Vulcanized splice failure. Here are some of the causes of that. Part of the issues associated with premature vulcanized splice failure would be improper step length. Now, those of you who have limited knowledge of vulcanized splicing, do you know what we're referring to when we say improper step length? How do you determine when you're looking at a belt whether or not they have the right step length?
You need to use the manufacturer's recommended specification based upon the PIW rating the belt is made with, right? So it really doesn't matter what belt tensions it sees, because you can't go calculate every system and try to adjust every splice to every system unless you're doing really exotic big stuff. But in general, you would use a step length, let's say 8 inches for a standard 110-pound fabric. So a 3-ply 330 PIW belt would use 2 8-inch steps. And you work up this scale of the step length. Greater the step length, the higher the tension the belt sees. It's rated tension, right? The belt is made under. But you try to manufacture to that, work to that standard. All belt manufacturers have splice length tables you can work off of to get those lengths straightforward, you know. You can always get in trouble, though, when you try to adjust the length and shorten it up yourself, because maybe you can. The belt sees a lot of low tension, but guaranteed sooner or later is going to cause you a problem. And then you always end that problem and say, okay, you got this big bad boy conveyor, something happened to the splice, it gets sent into an analysis. They do these analyses all the time, and they write back a report that said the splice is undersized by 60% or 40%, and that's your problem. So maybe it's not a big issue, but maybe the conveyor belt shuts down a power plant or something.
Who can take a stab at why they think the biggest issue of having too small of steps in the splices would be? Why would a vulcanizer willingly go out there and do that?
Because the press is bigger?
Press size?
Exactly.
Okay.
Just where you're doing it. Sometimes just
The location, how much room you have? Okay.
One of the things you got to take into account, if you're doing small belts with not a lot of tension and it's not a high critical belt, yeah, you can do all kinds of crazy stuff and get away with it. The first time somebody gets killed because a belt pulls in two and it's splice failure and it's determined as your splice, you better make damn sure you got a good insurance. Let me tell you what, I've seen lots of guys go out of business.
Step length, you could probably visualize from the side of the belt and get a pretty good idea if it's the right step length or not. But in truth, when we talk about improper adhesives, cleaning solutions, not enough pressure, improper temperature, the splice wasn't cured enough, it's taken out of the press prior to lowering the temperature, pulley diameters, tensions, build up on the pulleys, cleaners, splice installed backwards, excessive take-up weight, all those things can be visually seen. But stuff like the adhesives and not having enough pressure or temperature will represent themselves as premature failure, but might not, you won't be able to necessarily look at it and tell right away that that's what went on. Mechanical splice failure. The wrong fastener is installed. Fastener's not tightened down per the instructions, fastener installed incorrectly, pulley diameter too small, splice not protected, transitions are too short, pulley buildup, excessive take-up, improperly installed belt cleaners. Many of you may have seen this illustration before. I'm going to do it again for those who haven't given it any consideration. Whenever you're looking at a mechanical fastener or recommending a mechanical fastener, there's 3 pieces of information you're going to need to know. Whatever mechanical fastener you're using, those 3 things will be published in their literature. When you see up here the wrong fastener is installed, that could be alluding to a number of things. It could be a 2-ply belt that'll have a 3-ply fastener in it. A fastener that's rated to 330 PIW, but it's in a 220 2-ply PIW belt. What's going to happen? What's one of the concerns of these 3 elements that's going to be of first concern if they put an oversized fastener in a weaker belt? Pulley diameter is a biggie, but let's suppose that we got the pulley diameters cooking for us. What's going to be the next one? It could very well exceed minimum belt thickness of that bigger fastener. And if that's the case, then the splice is greatly compromised in its performance value as a result of those 2, the top and the bottom of that fastener, communicating with each other rather than just impaling themselves into the carcass of the belt. One of the things that I would mention to you is that if you have a failure with a mechanical splice and it's not a result of abrasion or corrosion attack, one of these three things have been violated. Simple as that. So you can render it all down to belt thickness, pulley diameter, tension. As far as the fasteners not being tightened down, let's say the fastener wasn't tightened down properly. Maybe it's too loose. Which one of these three things gets compromised? Tension. Okay? So you had a tension failure as a result of the fastener not being tightened down enough. A lot of times you're going to see fatigue accelerated on mechanical fasteners at the point where the skirt board rubber is contacting the belt, the staging area. Why is that? Abrasion. Extra drag, it's going to abrade out there. Many times their fastener selection, the type of fastener that they're going to use will be based upon its repairability. In other words, can I replace just that part of the splice without having to cut out the old one and put in a new one? There's the splice saver right here. When we talk about pulley diameters, if you're operating with mechanical fasteners, if you're operating over 75% of the belt's rated tension, and you are using a winged type pulley, we recommend increasing the pulley diameters that's published in our literature by 25%. Why is that? It's because if you're operating at high tensions and you're using wing type pulleys, you create pinch points right at the spoke of these self-cleaning pulleys. The fabric wants to break there, right at the point where the fastener is being introduced into it. So if you increase the diameter, you can have these fluctuations on the tail pulley, and it takes the pinch points away. If you use this type of a self-cleaning pulley, known as a spiraled wing pulley, anybody here sell these, represent these? See a couple of hands? Now we have a spoked pulley, but it has a wrap around those spokes. Still has the cleaning advantages of a wing type pulley, but now we have a smooth circumference, so there's no pinch points generated on a mechanical splice. In the real world, belting, minimum pulley diameters with belting are violated all the time. In the real world, mechanical fastener pulley diameters are violated all the time. Recommendations. But it's not always the case that it's the mechanical fastener that's causing, or that requires a greater pulley diameter than the actual belt itself. Okay? It will represent itself at the splice joint more quickly. You can see fatigue factors of a mechanical splice as a result of going over too small of a pulley diameter. Those types of fatigue issues are actually happening in a smaller scale all throughout the fabric of the belt. Mechanical fastener selection are the physical demands of the fastener and the environment in which it must operate. Determine maximum operating tension, minimum pulley diameter, speed of the belt, type, thickness of the belting, maximum temperature. Why do we need to know the speed of the belt? If I'm going to say here's a bucket of this, why would I need to know what the belt speed is? Well, remember we were doing the operating tension calculation? Okay, speed of the belt's going to have an effect on the outcome of what the actual operating tension of the belt is. Now, anybody here sell mechanical fasteners? How many times before you've sent out mechanical fasteners have you said, wait a minute, what's your belt speed? Doesn't happen. What it does come into play is that if you have excessive mechanical fastener fatigue or failure, belt speed is going to come into play. If it's not installed properly, if you say it's not tension or it's not compressed enough, it'll represent itself by a tension release or a tension failure. And typically with tension failures, what you see when you're inspecting a splice is rubber material that's elongating out from underneath the splice. And if you look at where the belt ends are located inside the splice, you'll see a separation. Do you recall when Mike was talking about fill fabric in the weave of the fabric in a belt? Well, it's incumbent upon the strength of that fill fabric's characteristic for the mechanical fastener to be able to hold into the belt. So when you get into cheaper grade belts, and they may not have as much fill fabric or cross-member fabric in the belt, mechanical fasteners aren't going to perform nearly as well in those belts. If it's under-installed or it's not compressed enough, it's not tightened down enough, on the belt, then it's reduced the tension value of that mechanical fastener, and it'll represent itself by seeing elongation out from underneath the splice and a separation of the belt ends that were formerly butted up together. You'll see a gap. If it's a pulley diameter failure, typically what you'll see on the outside edge of the splice is cracking and fissures in the profile of the splice, but it'll be in the top cover of the belt. And a lot of times when I'm talking to end users, I'll make this observation and they go, well, okay, so what? The top cover cracked. But what's really going on when you see those cracks in the belt that are following the profile? It's not elongating out from underneath it, it's cracked. You'll see little cuts in the belt. What do you suppose is actually going on? The fabric in the belt has ruptured or fatigued, and now there's no longer anything for that rubber to hold on to because there's a break in the fabric that it's cooked to. So it represents itself as a little break or a little fissure. So you've actually compromised the fabric in the belt when you see that type of thing going on, and strongly recommend that the customer rethinks what the splicing material is that they're using and resplices it as early as possible convenience. Because the next shock load, it may not hold up. Fastener selection table, heavy duty. Here's a bolt hinge plate, rivet hinge plate, screwed hinge plate, heavy duty staple plate. Okay, hinged fasteners affect which one of these three things the most? If you use a hinge fastener versus a plate type fastener. Pulley diameter. It's got a flex point. It's got a pivot point in the middle of it, so it'll flex over a smaller pulley, right? So you got this 3-ply 330 belt going over 8-inch pulleys. Can you use a hinged fastener on it? Sure. Can you use a plate fastener? Not so much. Are you violating the belt's minimum pulley diameter? Absolutely. Does it happen every day? Absolutely. Look at any road mill that's out there discharging belt when they're grinding, you know those big machines that are out there grinding up asphalt? Violate the hell out of it. Here we have solid plate, heavy duty. You got bolt solid plate, rivet solid plate, and screwed rubber and fabric, non-hinged type solid plate. Interesting, when you get to the screwed rubber, non-hinged fabric type, see how the pulley diameters drop down dramatically? It has that's this style of fastener's claim to fame is that it'll go around a smaller pulley without having a hinge fastener. Okay? But usually when you have something that has an advantage, you have something that's taken away in another performance value. Bolt plate fastener is a run-of-the-mill, used a lot type fastener, but the first thing you do to the belt is punch a hole in the carcass to be able to put it in. So you're compromising the belt just by pure installation. The rivet style of fastener actually swedges down through the weave of the fabric when those rivets go down through, so it doesn't disrupt the belt carcass. Consequently, you bump up your operating tensions much better because you're not damaging or removing the carcass of the belt. Then you have materials down at the bottom. When I talked earlier about abrasion or corrosion attack, you work with these various types of metals in order to compensate for those types of products that you're conveying. Measure the belt thickness. Measure the pulley diameters. So by the way, are we worried about the pulley diameters being too big? We don't care how big they are. We're just worried about them being too small. Okay? For tail or wing type pulleys, add 25% to the pulley diameter. This particularly comes into play when you're operating at that top 30 to 25% of the belt's rated tension. Hinge or solid plate. Use solid plate wherever possible because you don't have any sifting issues getting down in through the loop areas where the hinge pin is located. There's no moving parts. Hinge pins are considered moving parts. They're rocking back and forth when they flex around pulleys. Okay? So if you get particulates down in that hinge area, they start raking on one another and you're going to get a fatigue factor going on. You want to use a plate fasteners because the butt ends are sealed up. You don't have to have any sifting issues. Hinge fastener preferred on portable conveyors. We have smaller pulley diameters. Use hinge fasteners when belts need to be installed in tight spaces. Another advantage to a hinge type fastener is that you don't have to install it online. You can make it up in the convenience of your belt shop, take it to the customer. Here, all you got to do is throw it on, stick the hinge pin in, you're ready to go. Plate type fasteners, you nearly always have to create a workstation on the conveyor structure itself and install the plate type fastener. Special fastener materials designed for wet, corrosive, high temp, food industry, non-sparking, non-magnetic. Loop staple splice. This is almost predominantly, not always, but it's widely used only in underground coal. This is actually referred to generically as a European style splice. It's made domestically, but it originated out of Europe. And there's variations on it. It's not all just, doesn't all look exactly like that, but what it utilizes is a staple, heavy duty staple in a very large loop, and there's a whole bunch of narrow loops that surround the pin. Takes a special applicator tool to be able to install it. For industrial applications, there's not much more to say about it. It lends itself well to some underground applications where they prefer it.